Welcome to another Java tutorial. We're going to look at two more figures from Chapter 5. We're going to look at Figure 5.5 and 5.6. Figure 5.5 is actually called class sum, so it's up to you whether you want to use sum or Figure 5.5. This is not a very long program, and what we're going to do is total up all the even numbers between 2 and 20 inclusively. So we have a for loop. Remember that a for loop has the initializer, condition, and incrementer, and one statement. So to total everything up, we need a variable to hold the total. We initialize that to 0. And we're going to loop starting at 2, and we're going to end at 20. So another way of incrementing is to do plus equals. If we don't want to increment by 1, we can do plus equals for any other value. So here we're incrementing by 2. So this is a shortcut for an assignment statement. So it is equivalent to doing this. So we add 2 to number and store it back into number. And I think you'll agree that this is shorter and easier to read. So every time to the loop, we'll just add the number or the loop counter to total. Let's run this. And the sum is 110. So we can debug this, or we can just add more statements here. And we can print out partial sum and the loop counter. Like I said before, it's always good when you're a beginner to print stuff out inside the loop to see what's happening. Okay, so if you're not sure that the sum is actually supposed to be 110, we can look at what's going on at every step. So in the first time through the loop, sum is 2 and loop counter is 2. Remember that the sum started off at 0. And the loop counter is 4 the second time, so we're adding 4 plus 2, that's 6. And 6 plus 6 is 12. 12 plus 8 is 20. So check a few iterations for correctness, and generally you can extrapolate this to being correct. So we can assume that if we get all the way down to 20, 110 is the correct value. If you're mathematically inclined, you should know the sum of an arithmetic sequence and use that formula to verify your answer. Okay, let's look at the next example, figure 5.6. This is called class interest. And this is compound interest. And we're compounding it yearly. We start off with $1,000 and we're going to increase it at 5% per year. You'll notice that we're executing more than one statement. That's why we have the curly brackets. We're going to calculate the amount at the end of the year, and we're going to print it out for each loop. So let's just run this. Okay, so at the end of 10 years, you'll have $1,628.89 compounded at 5% per year. And you can just check year 1 for correctness. So 5% of 1,000 is $50. And on year 2, we make another $50 plus the interest on the $50 that we're compounding. So that's 5% of $50, which is $2.50. We can conclude that the extrapolation is probably correct. To calculate the compound interest, we simply use the power function. And if you're not sure what a function does, you can hover over it and it'll bring up the API for that function. So the first parameter is your base. Your second parameter is the exponent. So it takes this base to the power of this exponent. And math is a package in the Java library, and there's many functions in that package. you can go to the Java documentation to look them all up. It's good to look at the API to see what types of parameters the function is expecting. This one expects a double and a double as the parameter, and it returns a double. So these are floating point values. So this is not a terribly efficient function. As I've said before, there's always different ways to solve the problem. And let's rearrange this to make it a little bit more efficient. We'll set amount equal to principal. And we'll delete this. And we'll delete that. So instead of doing power functions, we can simply multiply the amount that we've calculated by the rate. So this is 1.05. We're increasing it by 5%. Let's run this. Try to remember the values over here. And we get exactly the same result. So we get $1,050, $1,102.50. And at the end, we still get the same amount, $1,628.89. So this is a little bit more efficient. It executes a little bit more quickly, and you don't need to use the libraries. So keep that in mind when you're programming. Try to find efficient functions. We're going to cover one more type of loop. This is called the do-while loop. Remember, the previous loop that you learned was a while loop. So this one, a while loop. So it's while condition statement. This one is a do, a statement, and then while. The difference here is that a while loop and a for loop can have the loop condition fail immediately and never execute this statement. If we set counter to 11 here, this would never execute. And again, if we set counter here to 11, this would never execute. So let's just take a look at that. 11 and run. So there's nothing printed. And switch it back to 1. Okay, so you can see the difference here. Let's take a look at this one. We'll run it. Okay, it prints out 1 to 10. If I change this to 11, it will print out 11. Okay, so it does this loop once no matter what. And this is useful for some cases where you're asking for a user input and you're using a sentinel. So you would want them to enter this loop once so that they can enter some input. Whereas in this case, you would have to put some code outside the loop and some code inside the loop to make sure that the user inputs something. So that's the difference with this do-while loop. It's not used as often as the while loop or the for loop, but it is used occasionally. And that completes this lesson.